Hello everyone, my name is Dhinson Dacpano, and in this video, I'm going to show you my final project for the IBM Advanced Data Science course. Here is the list of topics that you will expect in the next few slides. First, I'm going to explain a little bit about the use case and chosen dataset. Next will be about the environment setup and platform requirements. I will also show some visualizations about the data discovery and data exploration steps. What are the feature engineering methods applied? The available algorithms that solve time series problems. And finally, I'm going to show the results of my model performance evaluation and hyperparameter tuning. Here are the tools and libraries that I used for the completion of the project. First, I used Python as a language of choice, which is a very popular language in data science. I used Jupyter Notebook as my development environment. It's very useful at running my code interactively and combining it with the explanations. Google Colab is where I hosted my Jupyter Notebook. I also used its TPU hardware acceleration for parallel training. I used TensorFlow implementation of Keras API for rapid prototyping. I also used its powerful library for parallel training using TPU. I used NumPy and Pandas to load, extract, and prepare my dataset for training. Matplotlib for providing data visualization capabilities. And lastly, scikit-learn for scaling my data. These libraries have overlapping and complementary features depending on what you want to achieve. Here and in the next few slides, you will see the different visualizations of the data. Here you see some statistical values of the dataset, like mean, standard deviation, minimum, and maximum. Here is the plot of the Euro-USD price from 2005 to 2018. In this graph, you see the individual trend of the price each year. You also see the seasonality of the data monthly. It might look messy, but the price seems to converge on a narrow band around September and October. Here you see the yearly price trend and the seasonality quite clearly using the box plot. In the yearly trend, the price is going up from 2005 and reached the highest in 2008. We then see a downward trend from 2008 to 2015. In the month-wise box plot, you can see that the price has higher volatility during the summer and starting to die down around September. Feature engineering involves feature creation, feature scaling and/or normalization, data cleansing, and other feature transformation methodologies. For feature creation, I created new features from existing column by transforming the month, day, and hour components of the timestamp into categorical values. I also created new features by calculating the candlestick in currency trading terminology. This is just the distance between the opening and closing price. Another features I created are the top and bottom wick of the candlestick, or the distance between the opening or closing price to the high or low price depending on the price trend. In the rest of my models, I just used the actual prices. In feature scaling, I scaled the features to a range of 0 and 1. In data cleansing, I dropped the data before 2005, which contains some missing values. 2005 to 2018 data would suffice for this project. In time series problem, it is also necessary to create input with time steps. The data split I used is 60% training set, 20% test set, and 20% validation set. Here are some of the available time series algorithms. Linear regression using traditional artificial neural network. This is a simple network with no hidden layers. Forecasts are obtained by the linear combination of the inputs. LSTM. LSTM stands for long short-term memory. It is an artificial recurrent neural network architecture used in deep learning. LSTM has feedback connections and gates that regulate the flow of information and its internal states. This technique allows it to remember an entire sequence of data points and keep track of dependencies of past and new observations. ARIMA models are among the most widely used approaches for time series forecasting. The name is an acronym for Autoregressive Integrated Moving Average. It makes the time series stationary by combining both autoregression and moving average models. VAR, or Vector Autoregression Model, is used in predicting multiple time series variables using single model. In this project, I will use both linear regression using artificial neural network and LSTM. In the following slides, I will describe the architecture of linear regression model using artificial neural network and LSTM and their training parameters. We can then visually compare their performance. For linear regression model using artificial neural network, I used an input layer which accepts a matrix with 128 batch size and 24 series of past observations. Lastly, I added a dense layer with 1 neuron to make the prediction. The model was compiled using Adam Optimizer and mean squared error to update the weights and minimize the loss. In this result, we see that the linear regression using traditional neural network is able to perform well even on unforeseen data. I think this good result requires further investigation. In LSTM, I defined the input layer to accept a 3D tensor with batch size of 128, 24 past observations, and 1 feature. In other LSTM models, I used 4 features. Next is an LSTM layer with 72 neurons using soft sign activation function. Another LSTM layer was added with the same parameters. And lastly, a dense output layer with 1 neuron to make the prediction. Similarly, the model was compiled using Adam Optimizer and MSE loss function. The result is also quite good with LSTM using only a few layers. In the hyperparameter tuning step, I only chose to optimize the parameters for the activation function as tanh, ReLU, and soft sign. But the tuning can be done on any of the other parameters such as the learning rate, loss function, optimizer, batch size, number of neurons, etc. In this table, we can see that the fifth model have the best performance on the validation set. And this is the prediction result of the best model out of the hyperparameter tuning. So this marks the end of my presentation, and let me know your thoughts about it by putting your comments below. Hope you all have an amazing day. Thank you and goodbye.